Welcome everyone to Engineering Scale Models. I'm Jason, your host, and I do models. How is everyone doing today? I am here to talk more about my CMOS logic chip series. Today we're looking at the CD4017. It is a CMOS counter. And this one is counts to 10. It's to 10. Not in binary. Not in binary. It just lights up 10 lights in order from 1 to 10. So you can get these different ones that are binary counters and the decoders, but if I pull up this data sheet here, let's get this data sheet right here, you can see that the CD is a decade counter right here. It's with 10 decoded outputs. And it also mentions it right here that it is decimal decode display and things like that. It has an interesting pinout here. If you look at the pinout, the pins don't go in order. It does show you in order of the outputs here, from your 0 output to your 9 output, your carry out, and then you have ground on pin 8, and voltage source, or 5 volts in our case, is going to be VDD, that's pin 16. And then you have a clock pin on 14. Then you have a clock inhibit. You want to tie that low. You want to tie the clock inhibit low. That's this clock inhibit. And then the reset pin, you want to tie that low because it's an active high to reset the system. And then you can put an LED on each one of these, and you can make it light some LEDs, and that's what we're going to do. You can see the pinout down here a little bit better, pin 1 through 16. This one right here is the one that we're working with right here. A better look at the pinout. So, but let's go to the camera. But first, I want to show you the difference between a decade counter and a actual binary counter. So if I pop over here, everything should be fine. So this is this is close to a decade counter, but this is a binary counter. So if I turn on the circuit, it's going to count. That's 3, 4, 5, 6. Whereas the counter that we have is just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hit the carry, and then go back to 1, 2, 3. So it's like I said, decade counter almost, because this is a binary counter, so there's a difference there. So let's go to this view here, and we have our breadboard ready to go. I have my chip here, my 4017. Camera's still wide. Okay, so I'm going to plug this in. I'll plug it in right here. I don't have power on this board. I will be using my 555 timer clock circuit. I'll put a video up on how I did that at a later time. It's just a clock circuit. I can adjust the pulse speed. So let's hook up power and ground here. So now, if you look at this, so I want to tie reset low. So pin 15 is reset, so I want to tie that low because I don't want to reset it. I'm going to tie that to ground. And then I also want to tie that clock inhibit, which is pin 13. I want to tie that low. Pin 13. So I'm going to take my clock and I'm going to plug it into pin 14. And then now here's where it gets interesting. So I'm going to start with the carry out, and I'm going to work this way. So I'm going to start with the carry out, which is pin 12. Plug that in there. So that's our carry out flag right there. It's going to let us know that's pin 12. And then the 9th LED, or the 10th LED, which is the 9 output, is pin 11. Pin 11. And then number 8 is pin 9. It's pin 9 right there. Okay, number 7 is pin 6. So 1, 2, 3, 4, 5, 6. Pin 6 is right there. We got pin 5. Pin 5 is pin 1, or output 5 is pin 1. Then we need 4. That's pin 10. And then we need 3 is pin 7. So this goes weird. And I'm sure I'm going to hook up one of these wrong. 3, 2 is 4. Oh wait. Yeah. Okay, so let's try this again. Pin 3. 1, 2, 3. Pin 3 is LED 0. I got this messed up in here. So LED 1 is pin 2. And then LED 3 is pin 7. 3 is pin 7. LED 4 is pin 10. LED 5 is pin 1. Okay, and then LED 6 is pin 5. LED 6. No, wait a minute. What is pin 2? Pin 2 should be 1. Zero is 3. This one should be pin 2. Zero, 1, and 2. 2 should be pin 4. 2 should be pin 4. Okay, redo this, I messed up. So that's 2, 4. No. 0, 1, 2, 3. Pin 3. Pin 3 is pin 7. 3 is pin 7. Okay, so, and then this is pin 4. 4 is 10. 5. 5 is 1. Yeah, you see how I got screwed up? I was counting wrong. 6. 6 is pin 5. 7 is pin 6. 8 is pin 9. Is pin 9. And 9 is pin 11. There we go, we got it right this time. Pin 11. We just need to hook up 12 to our carry. 12 to our carry light. Okay, so I got my clock hooked up, and I'm going to hook 5 volts up to this and hope for the best, because that took me way too long to hook that circuit up. I'm going to use my bench power supply, and we're just going to hope for the best here. There it goes. It's counting. And you'll see when it gets to the end, the carry light will come on, and it skips this one for some reason. No, it says it's counting it. Definitely pin 2. Could be just a bad LED. So light 1, it does come out of pin 2. Could be a bad wire. Yeah, it looked like it worked that time. There it goes. There's a bad wire. I can make this go a little bit faster. By adjusting my clock speed. It's not the perfect clock, but yeah, I don't want to set up the function generator or whatnot. So this is how the 4017 CMOS a decade counter works. It just counts up to 10 with 10 one output on at a time and going in order from 0 to 9, and it has a carry bit, so you could actually cascade these together. So that's going to do it for this video. Visit on social media. You can also visit me on Patreon. Thank you for watching and have a fantastic day.